A very good evening, everyone. Good evening, friends. Welcome back to our sessions on Python for AI. So today we are going to understand a new topic, and it is related to data pre-processing. It is related to data pre-processing. What is data pre-processing? Data pre-processing is nothing but data cleaning, data cleansing. So that means the data that we have, we are going to clean it. We will be applying some steps. We'll be following some steps and we'll ensure that the data is clean. It is also called as data wrangling. It is also called as data wrangling or data munging. So all of these are different names given to data cleaning. We can also say it as data organizing. We are organizing the data. What exactly we are doing here? We ensure that the data is getting cleaned. Okay. And once if the cleaning is done, then what we are going to do with this clean data? We'll take this clean data and we'll apply some ML models. We'll build ML models. Machine learning models will be built on top of it. Or DL models will be built. Deep learning. So AI related models, algorithms will be used on cleaning the clean data. So one of the very important step, okay, you take any project in real time without data cleaning, no one can take the data. No one, first of all, can build an ML application or DL application. No. Data cleaning is a mandatory step. So without data cleaning, they generally don't go beyond it. They'll not go for the further steps before cleaning the data. So it's a very essential step that one has to take care of. And in this particular session, okay, as we have in total 9 steps, there are 9 different steps under data pre-processing. Okay, probably we cannot complete this all the 9 steps in a single session. So we are going to learn all these 9 steps in 2 sessions, guys. Okay, so that will be the agenda for today and tomorrow. What we are going to learn, it is data pre-processing, nothing but data cleansing. We are going to clean the data, right? Yes. So what are these 9 steps? Let us first of all understand the 9 steps that we have. Then we'll go further. Okay. Then we'll start step by step. The first one is called typecasting. What is typecasting? Typecasting is nothing but type conversion. It is nothing but we do type conversion. Okay. So when you want to change the data type from one to other, then we use typecasting. Right. Next to typecasting, we have handling duplicates. Handling duplicates. So we will handle the duplicates. What is a duplicate? We'll understand, guys. We'll understand what is a duplicate. Then post identifying the duplicates, they have to be removed. They have to be handled. Okay. We ensure that the duplicates removed from the data in step 2. Next to handling duplicates, we have outlier analysis. Outlier analysis. What are outliers? Outliers are nothing but extreme values. The extreme values that we have in the data are called outliers. Right? So these outliers, yesterday we have understood data visualization. Yes, under data visualization, we came to know, we understood a plot to visualize outliers. What it is? Which plot we use to visualize outliers in the data? What does a plot mean that we have discussed yesterday? Yes. Which plot did we understood in the last session, which helps us to, get the information of outliers? Box plot. Good. So we visualize box plot and we'll understand whether we have outliers or not. And these outliers will be treated. Why they have to be treated? We'll understand. Then next to outlier analysis, we have zero or near zero variance. What is variance? Variance is nothing but the spread in the data. Okay, so all these terminologies are related to statistics. They are related to statistics. Variance means spread. Spread in the data. How is the data spread? We'll understand by understanding the word variance. So if there is any data, okay, which has zero or near zero variance, we drop such kind of variables. Such kind of features will be removed, drop. Okay. Then next to zero and near zero variance, we have discretization. We have discretization or binning or grouping. All of these mean same. What do we do in discretization or binning? We convert continuous data into discrete data. What is continuous data? What is discrete data? We'll understand. Okay. Next to discretization, binning, the next step we have is encoding. Encoding. Okay. Where we convert categorical data, non-numeric data into numeric data. So that means if we have any categorical data and if I want to convert that categorical data into numeric data, that is called encoding. But first of all, why should I do encoding? What is the purpose of doing encoding? We'll understand. Okay. So all the questions that I'm raising, okay, all of the questions that we are raising here, each and every question will be answered when the step comes. Next to it, we have handling missing values. We perform imputation. So we handle the missing values. If there are any missing values, these missing values will be handled. Okay. Then the eighth step is called transformations. It is called transformations. What is the purpose of transformations? Transformations is nothing but we transform the data. The data will be transformed. But why it has to be transformed? We'll understand. And finally, the ninth step is feature scaling. It is feature scaling or feature shrinking. We scale the features. We are going to scale the data. What are features? Features are nothing but columns. So the columns has to be scaled. That is the meaning of feature scaling, guys. Okay. So we'll understand step by step all the steps of data pre-processing. That means in total 9 steps today and in tomorrow's session. Okay. So be active and you can also use it as part of your projects. Okay. If you are able to be clear on the concepts, You can apply the same steps on any given raw data and you can perform data cleaning. So this particular topic is very important, especially we follow the same in real time. Okay, in real time, we do the same on any given data. In order to clean it, we perform all these 9 steps. Some of the steps are mandatory and some of the steps are not mandatory, depending on the case. Right? Yes. So, let us start the step 1. What it is? Typecasting. It is typecasting. What is typecasting? Typecasting is nothing but conversion of data type. We are converting data type from one to other. That's it. Example, converting int to float or float to int. Okay, so it is nothing but typecasting. Probably if you go back on one specific day, we discussed type conversion. You remember? Type conversion. It's nothing but typecasting. But for typecasting, we are going to use the function called as type. We are going to use the function called as type. So this function as type will be used to perform type conversion. Right. So let me start. For this, I'm going to use a data set called cars. So let me, first of all, I'm going to import the required packages. So which package I'm going to import here? Pandas. What is the purpose of pandas, guys? Why do we import pandas? What is the purpose of pandas? Why we generally use pandas? For type conversion. Huh? Pandas we use for data manipulation. Good. We use pandas for data manipulation. I'm importing pandas as PD. So that means the entire folder, the package will get imported. And for this package, we are giving an alias name as PD. It got imported? Yes. So whenever you don't get any kind of error, exception, that means that specific line got executed. So what can I interpret from this? Pandas got imported to Python's memory. Then what am I doing? I'm reading the data from a Excel file. So this is the path of the Excel file. Okay. And we are going to work on a data set related to cars, automobiles. Yes, PD is the standard, universal standard alias name, shortcut name given to pandas. Good. So this is the path in which I have the cars data. Okay. Why are we using R in front of the path? What does it mean? R represents to consider this entire string, to consider this entire path in the raw format. It tells to the PVM that to consider this entire str data in raw format. And since we have the data in an Excel file, we are using a function called read underscore Excel. Read underscore Excel is the function that we are using from pandas. So that is why you see the dot. The dot represents hierarchy. From pandas, we are using function read underscore Excel. And to this function, we are passing the path, the location of the file, cars file. So when we execute this file, when we execute this line, what happens is It reads the data that is present in the Excel file, and that data gets stored in a variable cars underscore data. Let me do it. Is it done? Yes, it's done. So what is the size of the data? 428 rows and 14 columns. Rows and columns. First of all, what type of object is cars data? It is a data frame. What is data frame? Data frame is a two-dimensional object in Python which is similar to table. Okay. We have rows and columns in data frame. How many rows? 428 rows. How many columns? 14 columns. Okay. So let me open the data set. First of all, let me open it. Excuse me. So this is the data set that we are going to work on. You see, all the 14 columns, index will not be included, guys. From make is the first column. Type, region. Okay, in this way we have multiple columns. Right. And what about each and every record talking about? What is each and every record talking about? Because I can understand every column, the make of the automobile, the car. Okay, then the type and so on. But what is each and every record talking about? Each and every record, each and every row is talking about one car, guys. It is talking about one car. This is a car. Okay, see, the data that we are working is of cars. So every row represents a car data. So this is related to Audi. It's Audi. Okay, so we have the type, the mileage, everything, the length, weight, and so on. So that means whatever you see here are nothing but the details of cars. How many cars? 428 cars. How many features? 14 features. Clear? Yes. So we also have the data dictionary. The make represents the manufacturer or the brand of the car. Okay, who have manufactured the car is representing the make. And the model represents the specific model of the car even in the make. See, when you take a specific car make, you'll have multiple models. If you take Audi, there are A series, then C series, so on, X series, right? In the same way, you'll have multiple models. Then the type of the car, is it a SUV, sedan, micro, mini, so on. Origin, from where this particular car has been originated, the country or the region. Okay, then drivetrain. It represents the type of drivetrain. It means, you know, uh, this is specifically related to automobiles. Okay, probably you'll have front end, okay, and back, both the types under drivetrain. See, whether all of them are going to move when you're using the accelerator only on the front wheels or the rear wheels. Okay, that is what the drivetrain column is giving us the information. Then finally, we have MSRP, manufacturer's suggested retail price. As this data set is from US, we have the price in dollars. Okay, US dollars. So the manufacturer will also suggest the retail price. So that price column, the price details we have in MSRP. And engine size, the size of the engine in liters. So what is the capacity of the engine in liters? Next to it, cylinders, number of engine cylinders. number of engine cylinders. Next to it, we have horsepower. So horsepower rating of the car, HP. Then MPG within city and MPG on highway. What is MPG? MPG represents miles per gallon, guys. Mileage. MPG represents mileage. So within city and on the highway, the mileage changes, right? Because of the clutch movement, we generally use many times within the city. The clutch will be used for multiple times within the city. Probably the mileage will be less compared to the mileage that we get on highway. So we are capturing both the mileage within the city and on the highway. Then the weight in pounds. Okay, it's not in kgs, it's not in tons, it is in pounds. FPS system, right? And wheelbase we have in inches, the base of the wheel, yes. And finally, the length of the car, the length of the chassis, that is also we have in inches. So these are the 14 columns that we are going to use as part of this data set. Okay, so these 14 columns will be used and we'll be implementing our data pre-processing steps on it. Fine. So what am I doing? The first step is typecasting. Yes. Before typecasting, I would like to know the information of the data types. So what am I doing? I'm just printing the message. It is data types before typecasting. I'm going to print a message. Data types before typecasting. Let me do it. Yes. Print function has printed the message to the console. Next to it, I'm going to print the data types of each and every column. How? There is an attribute called dtypes. Okay. What does dtypes do? Dtypes will return us the data types. The data types associated for each and every column. Okay, what is the data type that origin has? What is the data type that drivetrain has? So that information we can get from dtypes attribute. We can get the information from dtypes attribute. Okay, just I'll write the question. Instead of dtypes, can I also use info function? Because when I use info function, I'll get the complete information of the data. So under this information, I will also have the data types, right? Yes. So either you use dtypes or you can use info function. When you use info function on the data frame object, you'll get the complete information of the data set in which you will have the dtypes. I hope it's clear. So now let me execute line number 36 and let us get the information of the dtypes that each and every column has. Dtypes will return only the data types, guys. See, the make. What is a dtype? Object. Model, object. Type, object. So that means what I can understand is for all the categorical columns, that means all the non-numeric columns. Do you see any numeric values in these columns? No, right? These are non-numeric. Make, model, type, origin, drivetrain. So for all these non-numeric columns, we'll get the data type as object. The data type will be object. Okay. Then what about MSRP, engine size? These are numeric, right? So what type of data that these columns has? I see the whole numbers, the integers in MSRP. So obviously the D type will be int. Then what values do you observe in engine size? In engine size, I see decimal values. So what will be the T type? It will be float, guys. So whatever the concepts that we have understood earlier on day 2, we have understood data types concept, fundamental data types. So that concept is related to here. We are just getting the data types of each and every column. If the column has integer values without decimal values, if it has only integer values, it will return int as the data type. If the column contains values like decimal values, the data type will be float. Float. What if the column has non-numeric values? The data type will be object. Clear? Yes. Now, let me perform typecasting. I'm going to perform typecasting. So let us understand this code, this line of code. Cars underscore data represents the data frame. Engine size represents one of the column. So that means I'm accessing a column from data frame. We have discussed, right, how to access a column from a data frame object. We have two different approaches. What are they? One is data frame object dot column. This is one way of accessing a single column. The other way is data frame object of column. This is the second approach. So that means I am following approach 1 and I am going to access the values. Then on this column, let me perform typecasting. For that, we are using as type function. We are using as type function and it says int 64. What is the data type of engine size? Engine size, the data type before performing typecasting is float because it contains decimal values, floating values. But what am I going to do? I'm going to perform typecasting. Type conversion is what I'm going to perform on engine size. Okay. For that, I'm using as type function. And this float values should be converted to int values. They have to convert it to int values. Okay. So that is what we are doing here. And where are these results getting stored? These results will be assigned to the same column again. Cars underscore data, the data frame, dot engine size. That means to the same column, the results have to be stored. The results have to be saved. So the clear understanding for this line, I hope it's clear. Because we are performing the typecasting on the right hand side and the results will be stored to the left hand side object. They are getting assigned using assignment operator. So what might happen, guys? Just go for a guess, wild guess. We know that, these float values will be converted to int values. So do you think, will the values get rounded off? Will 3.5 become 4? Or will 3.5 will become 3? What might happen? Go for a wild guess. Good question. See, that's why until unless if it is required, only then we perform typecasting. When you perform typecasting, you will have data loss. The decimal values will be lost. Good. But this typecasting is not a mandatory step in Python. I mean, under the data cleaning steps that we have, it's not a mandatory step, my friend. Okay. In some cases, a few algorithms, they want only the data in this particular type. Okay. In those cases, we use typecasting. We perform typecasting. But here to understand, we are going typecasting. We are understanding typecasting. Okay. But the actual reason is when you perform typecasting, there will be data loss. Good. That is what I'm telling. Until unless if it is mandatory, only then we'll go ahead. If not, we'll ignore the steps. So what do you think? Will 3.5 will be rounded off to 4 or will it be rounded down to 3? The answer is it will not be rounded off. No, it will not round off the values. You see what's happening. Is it done? Yes. Let me open the data frame again. What happened? 3.5 became 3 guys. So that means the decimal values that we have, all the decimal values will be removed. That is what typecasting is performing. Clear? Understood or not? Yes. Now, let me get the data types after performing typecasting. We have performed typecasting, right? On the column engine size. So, let me do one thing. I'm going to print the data types after performing typecasting. So, I'm using the same attribute d types. The same attribute d types is being used. And this will return me, the data types post type conversion. You see engine size? It became int 64. Clear? Yes. Now, what we are doing in the next line? In the next line. Again, we are performing typecasting here. Yes. On which column? MSRP. Maximum suggested retail price. Sorry, manufacturers, suggested retail price. Okay. So I'm performing typecasting on this MSRP column. The data type that we have for MSRP is int, and I'm going to convert these values to float. So what will happen for MSRP column? For this column, what will happen? You see, all the values they are integers, no decimal values, nothing. So what might happen? The values will be, yes, converted into decimals. How? By just placing zeros. See, for all the values, you'll have dot zero, dot zero. Even though if you have zero, that means it is a decimal number. When you have decimals, it represents float. Clear? Yes. Now let me print the data types post conversion. Again, let me check the data type of MSRP. It's float. It is float. Done? Yes. So I hope it is clear, guys. Typecasting, right? It is simple. Whenever there is any requirement, if you want to perform, the conversion of one type to other, we perform typecasting. If not, we ignore this step. Then the next step in the data preprocessing is handling duplicates. Handling duplicates. What do you mean by a duplicate? First of all, if you know what is a duplicate, then you can handle them. Am I right? Yes. So let us understand what is a duplicate first of all. Assume that you have a data set in this fashion. There are 4 columns and the values are like this. Right. So assume that you have 4 columns A, B, C and D. So these are the 4 columns that we have. Right? And you also have the data in those 4 columns? Yes. These are the 4 columns. Now, if I ask you to tell me the duplicates, what will be your answer? Good. Any 2 rows having same values are duplicates. So tell me the duplicates that are present in this data set, guys. In this data set, tell me the duplicates. This is record 1, record 2, record 3, record 4, record 5 and record 6. So tell me the duplicates that we have in this data set. Understood? Any 2 rows having same values. So tell me which 2 rows have same values. 1 and 5. Okay, my friend says record 1 and record 5 have same values. So that means this one and this one are duplicates. They are duplicates. Okay, so understood what is a duplicate first of all? Duplicate means any 2 rows have the same values under the same columns. Okay, you cannot tell, I also say that row 1 and row 3 are also duplicates. No, just having 1 and 2 and 2 in the same columns, that doesn't mean it's a duplicate. The entire row should match with the other row. Only then you can say that data has duplicates. If that is the case, all the columns we have duplicates. So the duplicate means any 2 rows, 2 records have same values at the same place under the same column. So record 1 and record 5 will be duplicates here. Not record 1, record 3 or record 1, record 2. No. If you take employees' age, can't we have employees of same age? Yes. We can have employees, students with same first name. Right? So that doesn't mean they are duplicates. They are not duplicates. If the entire record matches with the other record, then it is called duplicate. So here, what am I going to do? I am going to handle the duplicates. But first of all, since this is a small data set, by going through the records, we were able to identify the duplicates. Fine. But what if I have given you a big data set? If you are working on a big data set, okay, will you go through each and every record manually? Impossible. Impossible. Right? So, what we have to do is, we have Python functions. Anyways, we have Python functions And these functions are going to reduce our effort. Why duplicates have to be handled? Because instead of passing the same record for multiple times to the model, the next phase, y is equals to f of x. Okay, we generally drop the duplicates. The repeated data should be dropped. There is no use of having the repeated rows, the repeated records. So that is why we have to remove the duplicates. Right? Yes. So let me, start working on duplicates. For this, I'm going to import the package called pandas as PD for data manipulation. And the data set that we are going to work is different, guys. It is cars data set only, but there is a small, change. A few duplicates were being added to the cars data, and you know, we have it under this cars underscore duplicates data set. So this is the data set on which we are going to work. Okay. So this is present in a CSV file. The data is present in a CSV file. So what am I going to do? I'm going to read the data. I'm going to read the data. How? Using read underscore CSV function. Using read underscore CSV function from pandas, I'm going to read the data, and the data will be stored in same cars underscore data. So it means it overwrites. Done. How many records you see? Just 431. And in these 431 records, there are duplicates. There are duplicates. So how to, first of all, before dropping the duplicates, I would like to get the information of the duplicated records. The records which are duplicate, I would like to get their information, which records are duplicates. Okay, I'm using a function duplicated. I'm using a function duplicated. So this duplicated function will return the information of whether the record is a duplicate or not. Whether the record is duplicate or not. Okay, so cars underscore data is the data frame, and on this data frame we are going to apply duplicated function. We are going to apply duplicated function. This duplicated function will return as a series object. It will return a Boolean series object. What is a Boolean series? Series object is nothing but it's a one-dimensional object in Python which has multiple rows and only one single column. Which has multiple rows. You see 431 rows, but how many columns? Only one. Let me open it. You see only one column. And what values do you find inside it? I see only false. False or true. So that means I see only Boolean values. Yes. A duplicated function will return a Boolean series. It will return a Boolean series. Boolean values. What values we have under bool type? True or false? Yes. So this is a Boolean series. What does false indicate? What does true indicate? False means that particular record is not a duplicate. What about true means? True means that particular record is a duplicate. I see here a duplicate. So that means record 26 is a duplicate. Oh, record 26 is a duplicate. If I go in this fashion, I will have duplicates. Wherever it is marked as true, that particular record is a Boolean, that particular record is a duplicate. Yes. So I'm going to, we have understood the output of duplicated function, right? But how to get the information? Okay, before that, I'm going to print a message, Boolean series indicating duplicate rows. The message will be printed and I'm going to print the series object duplicate. So the series object will also be printed. All the 431 values starting from index 0. Yes, true represents duplicate and false represents it's not a duplicate. But I cannot sit and count, right? I cannot sit here and count how many trues I have, how many values I have. I mean, how many false values I have and how many true values I have. I'm more interested in true values. Apart from false, I'm more interested in true Boolean values. Why? True represents duplicate. So I would like to get the information of number of duplicates. So what logic should I use to get the number of duplicates? What logic should I use to get the number of duplicates? Try it out, guys. Go for a wild guess and give me your answers. Which logic should we use? If I sum up these values, the values that I have here, if I sum up these values, can I get number of duplicates? Yes. How come? Internally, false is recognized as 0. What about true? True is recognized as 1. So, when you sum up these values, obviously 0 plus 0 will be 0 only, right? All of these are zeros. When you add all of these, you'll get the output as 0. False. But if there are trues, what happen? The 1 will be added. So that means the end value that you get, the x number, will be number of duplicates. It represents number of duplicates. So I'm using sum function. I'm using sum function. Sum function is being used on the series object. On the series object, I'm going to use sum function and this will return me the number of duplicates. So let me print them. It is 3 duplicates. So that means there are 3 duplicates. Understood? Fine. But are you sure that the first one is original and the last one is duplicate? The three duplicates that we have in the data set. Okay. So which one is duplicate and which one is original? Because if you go back to the previous example, the 4 columns that we have discussed in the data, in which we have told record 1 and record 5 are duplicates. Okay, we told one of this is a duplicate. So that means one is original, the other one is duplicate. So which one is original, which one is duplicate? How do you tell it? How do you tell which one is original, which one is duplicate? So for this, we have a parameter called keep. There is a parameter called keep. What does this keep parameter does? The keep parameter will return us which values to be marked as duplicate. Either the first value or the last values or all the values. So for this, Let us understand the documentation of duplicated function. We have to understand the documentation of duplicated function. Okay. I'm opening a browser. And I'll keep it as duplicated function. See, I'll keep it as duplicated function. And I'm going through the documentation, guys. Documentations are must and should from here onwards. Okay. So what does duplicated function does? It returns Boolean series. Did we get Boolean series? Yes. It's a Boolean series. And within the function, how many parameters do you observe? There are two parameters. What are they? They are subset and keep. What is subset and what is keep? Subset represents a subset of data. You can also work on only a subset of data. Here, in our case, we are taking the entire data, right? On this entire data, we are going to identify the duplicates. If you don't want to work on the entire data, if you just only want to work on the subset of data, you can also work on subset of data. So I don't want to work on subset of data. I'm not passing any value for subset. But for keep, if I don't pass any value, which value will be considered? First as the value. But what is keep is equals to first? What does keep is equals to first means? Keep represents, it determines which duplicates to mark, which values to be marked as duplicates. And keep takes three different values: first, last, and false. The default value for keep is first. If you don't pass any value to the duplicated function, by default, the value will be first. A default argument, a default parameter. So what does first means? First means to mark duplicates as true. The duplicates will be marked as true. Okay. Except for the first occurrence. So that means in our example, record 1 and record 5 are two duplicates. Yes. What is the first occurrence? 1. So for the first occurrence, the keep is equals to first will mark as false. But rest of the duplicates in the data will be marked as true. Clear? Except for the first occurrence. So for the first occurrence, it marks false. Okay, when you pass keep is equals to first, it takes that the first occurrence is the original, followed by the rest of the occurrences in the data will be marked as duplicates. Fine. What does what does keep is equals to last means? Keep is equals to last means mark duplicates as true. So duplicates will be marked as true. But except for the last occurrence. So that means it goes in the reverse direction. In this case, keep is equals to last. Record 5 will be marked as false. And record 1 will be marked as true. Understood? So, when you change the value for the key parameter, your duplicates will change. That means the records that were being marked as true for keep is equals to first, those records will be marked as false if I go with keep is equals to last. So, the values will change. What if keep is equals to false? If keep is equals to false, it marks all the values, all the records will be marked as true. So that means both record 1 and record 5, both of them will be marked as true. So that means there is no original. So this is not generally followed because even the duplicate and the original, both of them will be marked as duplicates. Okay. So we either choose first or last. Why? If I take keep is equals to false, how many duplicates I'll get? In this case, I'll get two duplicates. But in fact, only one is the duplicate. One is the original value. Okay. So that is why we generally go with keep is equals to first or keep is equals to last. Clear? Yes. So let me go back and let us prove it. Let me change the value for keep is equals to last. Okay. Even though if I change the value for keep is equals to last, the number of duplicates will be same, guys. The number of duplicates will not change. It will be same. But the marking will be changing. The marking for the duplicates will change. Right? So let me execute and store the results to duplicate underscore last. So this is also a series object of size 431. You see here, record 7 is a duplicate. But in the earlier case, is record 7 a duplicate? No. The marking will change. Clear? Yes. So let me print them to the console. Either I can use print function, if not I can directly use the variable. I can use the variable name and I can print it to the console. Done. Next to it, what do we have? I'm also trying with keep is equals to false. I'm also trying with keep is equals to false. When I try with keep is equals to false, okay, so the duplicated function is going to mark all the originals and the duplicates as the duplicates. So how many duplicates can you expect? How many duplicates can you expect, guys? In line number 80, what can your answer? Just go for a guess. Here, when the key value is first, I got 3 duplicates. When the key value is last, again I see there are 3 duplicates. But what will be your response when the key value is false? How many duplicates might be there? Just go for a guess. Come on, guys. How many duplicates can you expect? Any number? Fine. I see no number. So let me execute. Done? Yes. It's done. And where are the results got stored? The results got stored in duplicate underscore all. Yes. The answer is 5. Good. But in general, majority of us will think that the answer is 6. But it is not 6, guys. There is a specific row which got repeated for twice. Okay. So here we have, let me use this logic underscore all. And let me print the number of duplicates. It is 5. Clear? So the answer is 5. But in general, what people, I mean, the mindset of the people will be like, there are 6 duplicates because one being repeated every time. No. There is a specific row which got repeated for twice. So that is why you see 5 duplicates. Why? One record repeated for once, what one record repeated for twice. But keep is equals to false will mark both original and the duplicate as a duplicate. So 1 plus 1 plus 1 plus 2, 5. Clear? Yes. Then we have understood how the duplicates have to be identified. Okay. I'm going with a function called drop underscore duplicates. We understood how to identify duplicates, but that is not our agenda. The duplicates have to be dropped. There is a function called drop underscore duplicates. There is a function called drop underscore duplicates. This drop underscore duplicates function will return us. It is going to remove the duplicates from the data frame, and those removed, the clean data which does not have duplicates will be stored in data underscore first. It gets stored in data underscore first. So let me execute. Done. What is the size of data underscore first? 428, 13. Why 428? Because 3 records, the 3 duplicates were being dropped. Here. In the same way, drop underscore duplicates also have the key parameter, guys. Like how duplicated function has, in the same way, drop underscore duplicates function also have the key parameter. Okay. So I'm going to print the shape of the data underscore first. I'm going to print the shape of data underscore first to the console. It is 428, 14. 428, 14. So 3 duplicates were being removed. Now, let me try drop underscore duplicates with key parameter as last. So that means if I don't pass anything, the key will be first. Key takes first. How can I understand it? If you go through the function drop underscore duplicates. Yes. See here, it will return a data frame with the duplicate rows removed. The duplicate rows gets removed. And the same 2 parameters, subset and keep. Next to subset and keep, what do you have? You also have some other parameters that are not required. And what does keep parameter does? Keep parameter is actually, it is going to determine which duplicates to keep. which duplicates to be kept in the data. Right? So when I use keep is equals to first, it drops the duplicates except for the first occurrence. So the first occurrence values will be kept as is and the duplicates will be dropped. Coming to the last, keep is equals to last. The duplicates will be dropped except for the last occurrence. And finally, keep is equals to false will drop all the duplicates. So it is similar to duplicated function, but a small difference. Where this drop underscore duplicates function will drop the duplicates. So now let me try with keep is equals to last. I'm going to try with keep is equals to last. So where are the results getting stored? Data underscore last. What will be the size of data underscore last? What will be the size of data underscore last? This object. After executing line number 88, we'll have a data frame called data underscore last. So what will be the size of it? It will be of same size, guys. 428, 14. See, either you go with first or last. The number of records will be same, but the same records will not be dropped. And finally, I'm also trying with keep is equals to false. I'm going to try with keep is equals to false. When I use keep is equals to false in drop underscore duplicates, it will drop all the duplicates including original. Yes. It drops all the records. So tell me what will be the size of data underscore number underscore duplicates. What will be the size? What will be the size, guys? How many duplicates did we identify here? When I used keep is equals to false, 5, right? So 5 of them will be removed. All the 5 will be removed. So the size will be 426. 426, 14. Understood or not? Anyways, so with this, we have also understood how duplicates have to be removed, how duplicates have to be handled in the data. So the same approach can be followed on any data set, on any given data set. Okay, if you want to identify duplicates, we use duplicated function. If you want to drop the duplicates, we use drop underscore duplicates function. Done? Yes. So with this, we also completed step 2. Let us go to the step 3. It is outlier treatment. What are outliers? What are outliers? Outliers are nothing but extreme values. They are extreme values. The extreme values that we have in the data set are called outliers. And these outliers have to be treated. If you don't treat these outliers, there will be a significant effect of the model performance. See, post cleaning the data, we'll build a model. And this model helps us to perform, it helps us to get the predictions. So when you don't clean these outliers, what happens? These outliers may affect the model performance. So that is why we handle the outliers. We treat the outliers. Right? So in order to treat these outliers, we initially visualize a plot called box plot. Box plot is also called as box and whisker plot, also called as whisker plot. What are the formulas does box plot use for calculations? Lower limit, Q1, Q2, Q3, and this is will be upper limit. So in order to calculate lower limit and upper limit, box plot minus 1.5 times of IQR. What is IQR? IQR is interquartile range. So in order to calculate lower limit and upper limit, box plot uses this formula. For calculating lower limit, the formula will be Q1 minus 1.5 times of IQR. And for calculating upper limit, the formula will be Q3 plus 1.5 times of IQR. So the Q will be adjusted accordingly and the sign will also be adjusted. The extreme values. And the values which are beyond these limits are called outliers. They are called outliers. And these outliers, we have to treat them. There are multiple different techniques that we use to treat the outliers. Okay, so here we are going to learn different types of techniques by using a package directly, by using a package called feature underscore engine, where we use a function called winsorizer. Okay, if not, we can implement 3R technique. RRR. It's not Rajamouli's movie, guys. Okay, so there is a technique called RRR. What is this RRR? We'll understand. Okay, then before that, you have to understand the purpose of box plot, because box plot is the only plot which gives us the information about outliers. And the primary purpose of visualizing box plot is to understand the data distribution. I can also understand the data distribution, how the data was distributed. Right? So, post visualizing a box plot, if you find that the columns, if any of the columns have outliers, we treat these outliers. We treat the outliers. I hope it's clear. Right. Now let me start by importing the required packages. I'm going to start outlier treatment, the step 3 of data preprocessing. So what are we importing first? Importing pandas as PD for data manipulation. For data manipulation, we are importing pandas as PD. Then next to it, what are we doing? I'm importing NumPy as NP. What is the purpose of NumPy? Numerical Python. Purpose of NumPy. Why do we use NumPy, guys? NumPy helps us for conducting basic mathematical calculations. Pandas, data manipulation. NumPy, for basic mathematical calculations. Matplotlib.pyplot. Why did see all these packages we have understood in the last class itself, right? So you should respond to the questions. Don't sit idle. Matplotlib.pyplot. We are importing pyplot from matplotlib. Pyplot is a module, right? Yes. So matplotlib.pyplot. For data visualization and Seaborn. Seaborn as SNS. What is the purpose of Seaborn, guys? For data visualization again. Then what makes the difference between Matplotlib and Seaborn? It is an advanced package for visualization. Good. Then I'm reading the data again. Okay. The same data that we have in the Excel file. I'm reading it and I'm storing in the data in an object called df. So df is a data frame object of size 428, 14. So on this data, I want to generate a box plot for all the columns at a time. Is it possible? Yes, it is. Instead of visualizing box plot on one column at a time, I am going to visualize box plot on all the columns together. In the previous session, we have visualized box plot on one column at a time, right? But here we are going to do on all the columns. So what does df represent? The entire data dot plot function. Dot plot function. Plot within the function I am passing multiple parameters. So you can go through the documentation of plot function, guys. The first parameter is kind. What kind of plot would you visualize? I am passing it as box. So that means I am going to visualize a box plot. Next to it, the figure size 12, 8, which means 12 is the width and 8 is our height. Width and height, the size of the figure. Subplots. Would you like to get the subplots within the figure? Yes. True. So that means within the figure, we'll have subplots. Multiple plots. Sherry. What does this sherry means? Sherry means to get y-axis. To get y-axis for each and every plot, this sherry will take either a Boolean value, true or false. If you pass true, the y-axis for all the columns will be same. But when you keep false, it ensures that all the subplots in the figure will have its own y-axis. Okay, even I'll talk about this, guys. When we visualize the box plot, I'll talk about it. And the colors that I'm passing the color parameter as, the boxes should be blue in color, the whisker should be in orange in color, and medians, the Q2 value should be black in color, caps, upper limit, lower limit, the caps, whisker should be in red color. So I'm passing the values, I'm just passing a dict object, keys, values, and patch artist. So would you like to fill the color with the, would you like to fill the boxes with the color? Yes. So the box in the box plot will be filled with which color? Blue color. Show flyers means, would you like to show the outliers in the plot? Yes. So I'll keep it as true. So I'll execute. Okay. There are 3 more lines. TLT dot subplots underscore edges. From pyplot module, I am using a function subplots underscore adjust function, which means to adjust the subplots with the space. The space between the subplots should be 0.8. Between the subplots that we get, the space should be 0.8. And title function from pyplot. This will give us a title for the plot, for the visualization. Box plot for all numerical columns. The question rises, this code is for box plot, right? Yes. So, first of all, can we visualize a box plot on numeric columns? Yes, obviously. In the same way, can I also visualize box plot on categorical columns? Non-numeric columns? Impossible. How can you calculate the lower limits, upper limits for non-numeric data? Right? So, we'll not get box plot for entire 14 columns. Out of 14, we have 9 numeric and 5 categorical. So, we'll have 9 box plots in the figure. And plt.show function will display the box plot. So, I'm going to execute all the lines of code together to visualize my box plot on the entire columns. All the numeric columns. See. The title and you see the Sherry. Sherry is equals to false means for each and every plot you will see its own y-axis. Depending on the values that column takes, it gives own y-axis. If you keep Sherry is equals to true, you will have the same y-axis for all the box plots. Never ever do it, guys. You cannot interpret the results properly. Why? Because if you see the first two plots, the first box plot, the values are very high. Because this is the box plot for manufacturer suggested retail price. Obviously, price will be high in number. But engine size, depending on the liters capacity, the engine capacity, we have the numbers they are single digit numbers. So, when you keep the Sherry is equals to true, you cannot interpret this box plot. That is why Sherry should be false. And what do you observe? I observe that all the columns, all the features, the numeric columns have outliers. They have outliers. You see, in each and every plot, there are outliers, extreme values. So these outliers have to be treated. We have to treat these outliers. For that, initially, I'm going to calculate the limits, guys. I'm going to calculate the limits. So what is the formula for the limits? For calculating limits, we use the formula like Q plus or minus 1.5 times of IQR, where IQR is nothing but Q3 minus Q1 in the formula. IQR is calculated from Q3 minus Q1. 75th percentile minus 25th percentile. Then, what is the formula to calculate lower limit and upper limit? What is the formula that we have for calculating lower limit and upper limit? For calculating lower limit, the formula is Q1 minus 1.5 times of IQR. And for calculating upper limit, the formula is Q3 plus 1.5 times of IQR. So using these formulas, I'm going to calculate the limits for all the columns. I'm experimenting with one column You can apply the same logic for all the columns. Which column am I taking? I'm taking MPG city. I'm taking MPG underscore city column. So this column I'm taking and I'm calculating first of all Q1, Q3. Q1 is nothing but 25th percentile. Yes. So for which column you are calculating? MPG city. So the values of MPG city will be used and it calculates 25th percentile. For calculating the percentiles, we have a function called quantile. Quantile is the function will be used for calculating the percentiles. And these percentiles will be captured. This will return me Q1. I'll use the same logic and can I get Q3 by just changing the value? Yes. Q3 represents 75th percentile. Q2 represents 50th percentile. So I'll use the same logic and I'll calculate Q1, Q3 and IQR. And I'll also calculate IQR because IQR is nothing but Q3 minus Q1. Right? So Q1, Q3, IQR will be calculated. When you have all these values, can you calculate lower limit, upper limit? Yes. I'll substitute these values, the same formulas, guys. I'm just converting into the logic. That's it. Lower limit and upper limit will be calculated. Okay. So let me do it. Initially Q1. What value do we have for Q1? It got stored in Q1. It is 17.0. In the same way, Q3, 21.25. So 21.25 minus 17 will give us IQR. That means 4.25. Where is IQR? Okay, did I exclude it? 1 minute. Yes, you see IQR now? IQR is 4.25. In the same way, let us go and calculate lower bound, the lower limit. I'll substitute all the values. Q1 calculated, IQR calculated. So this will calculate me the lower limit for MPG underscore city column. The lower bound value is 10.625. In the same way, let us also calculate the upper bound. The value is 27.625. So that means any of the MPG underscore city values, if they are less than 10.625 or if they are greater than 27.625, they are marked as outliers. Right? They are marked as outliers. So these outliers will be treated, guys. We are going to handle these outliers. For that, we are going to use the concepts of RRR, triple R, rectify, retain, and remove. So we'll be learning RRR technique, next to which we'll be also understanding Winsorization. We'll also understand Winsorization. This is also very important function in order to handle the outliers. In order to handle the outliers in the data, we also use Winsorizer. One of the technique, Winsorization. It is called Winsorization to handle outliers. So we have multiple methods. So all of this stuff we are going to understand in the next session. Okay. In the coming session, we'll be understanding the types for handling, the outliers. So any questions so far in the concepts that we have discussed? in today's session: typecasting, handling duplicates, as well as, you know, even handling outliers, outlier treatment. So far, whatever we have understood, we are going to, the continuation part will be tomorrow, guys. Okay. Ensure that you join on daily basis, because this is one of the important topic that you are going to learn, and you can use the same and you can work out on projects. Multiple projects can be done. Data cleaning is a mandatory step, right? So I'll stop it here. And any questions? First of all, any technical questions? Yes, you have to practice on multiple data sets. Only if you do practice on multiple data sets, you know, you'll understand the concepts. It's not just listening to the sessions. Okay. When you do on multiple data sets, you'll learn. So take the data sets and work out on the data pre-processing steps. Yes. And moreover, tomorrow we are going to start a new internship batch. Okay. So batch 4 is going to start tomorrow. Do share across your connections, guys. It's a free internship. You need not pay anything. So tomorrow it will be a live demo session in our channel. And next to it, on the next day, we'll have an orientation session. Whoever wants to complete the internship, okay, you can be part of our internship journey as well. So this internship will be for 45 days, right? So do share across your connections. A free internship, right? Any questions? Your questions will be addressed. So tomorrow we have internship at 7, guys. Okay. So you'll have a demo session followed by, okay. So do share across your connections. Right. So anyways, the feedback link will be posted tomorrow. Okay. So thank you so much for joining and making the session interactive. Before you leave, ensure that you also subscribe to our channel, because we are going to come up with amazing content in the future. And moreover, hit on the like button, guys, a kind of support that you're going to give from your side. And if you have any kind of questions, you can use the comment section. You can post your comments, I mean, your questions. All your queries will be addressed, right? So do share across your connections. If you find that the session went well, hit on the like button. Okay. So that one thing is what you're going to do from your side, right? Nothing else behind it. Right. That's all for the day. Again, we'll meet in the next session. So please join on time, and tomorrow we'll join and we'll start with the session. We'll just continue from wherever we have stopped. Thank you so much, guys. Have a wonderful day again. Bye. See you.